Hi, I'm Jacob Bleacher. I'm a geologist. That means I study rocks and dirt on the Earth and planets. This is Ask NASA. I'm here to answer your questions. What is unique about the surface of the moon? Well, the moon is quite unique from the Earth. It has no atmosphere. There's no air to breathe. What that means is that the processes that have occurred on the moon are all preserved there in the rocks. For instance, if you look at the moon from the Earth, you may see circles. Those circles are impact craters. Let me show you. Except, making craters is really dirty business. I need my crater making poncho. Now we're ready. Let's pretend this is the surface of the moon. It looks a lot like this. That's one crater, but the surface of the moon has many more.
Oh, that was a good one.
On the moon, these craters have formed over time, and as you saw, material from each crater buries the previous ones, making this very rough terrain. In that terrain, at the pole, there are some craters that we believe have water ice trapped there, and they never see the sunlight. That's good for science, and could also be a resource that helps our astronauts survive. Why study moon rocks? Well, besides the fact that rocks are awesome, each rock is kind of like a person. It has its own fingerprint. We talked about impact craters. That's recorded in the rocks. Whether or not ice or water has been near there, that's recorded in the rocks. It tells us the history of the moon. What tools will astronauts use to explore the moon? Well, hopefully we'll have plenty of tools for them. For instance, something like this. This is a hammer like you would use here on Earth. It's a geologist's best friend. It helps us to break up rocks and select samples. We could also use things like rakes and shovels to help us find the right kind of material to bring home. Eventually, we could be using tools more like this. This tool is an X-ray fluorescence spectrometer, or XRF. An XRF basically shoots X-rays at a rock and then detects what comes back. And as I talked about before, rocks have unique fingerprints. This helps us to determine what that fingerprint is. Our astronauts will also use rovers, like this model that you can see right here. These vehicles are designed so that they can help us move around on the surface. Well, this tool is 3D printed, but this is just a model of an XRF. But right now, we're actually testing 3D printers in space on the International Space Station. It'd be really helpful if we can use 3D printers to design the tools that we need. How are we preparing astronauts to investigate the moon's surface? Well, we have to practice here on Earth. The way we do that is we talk to them in the laboratory and classrooms, and we also take them out into the field, places like Hawaii or Iceland or Arizona. Places where there are similarities to what they might experience on the lunar surface. We're really excited to send humans to the moon with the Artemis program. First woman and the next man will be going back there by 2024. Together, they'll be able to explore the surface of the moon. Right now, our plan is to send crew to the surface of the moon once per year and bring more supplies to the surface so that we can explore more and more of the South Polar region. That is a great question. The first thing that's going to be very different is that during Apollo, the sun was overhead. But at the South Pole, the sun is always going to be right on the horizon. That means we'll have really long shadows and areas that are very dark. It's going to be very different. We really are exploring a brand new terrain where no one has ever been. The studies we'll be trying to do are looking at and understanding perhaps the water cycle on the moon. And we really want to understand the processes that lead to that water being preserved there. Ooh, that's an intriguing question. First of all, we can see fairly deep into the interior of the moon by looking into craters. That's kind of our natural laboratory for getting at the inside of the crater. Every time a crater forms, there's an explosion that moves rock up and out from inside of the moon. So our astronauts walking around the rim of the craters can pick up rocks that came from deep inside. The bigger the crater, the deeper the rocks. Well, in fact, we are aiming for farther out. Eventually, we want to get to Mars. But first, we're going to go to the moon and learn some really important answers to questions that will help us survive the trip out to Mars here, because I guarantee you I'm going to have a lot of questions for them when they get back.
Do you have a question for NASA? Send your questions to our experts using hashtag AskNASA. NASA.